Yes, sir. Let's start.
Yes. Sir. So hello all. Welcome to the iitiansgateclasses classes. So in this session, we are going to cover uh, mechanical solution for GATE 2022 Set 1. And particularly in this session, we are going to cover strength of material and machine design questions, right? So coming to this section B, that is nothing but design section, is strength of material and machine design. In this, we can see that the question type as well as the number of questions that were asked. So the one mark question they ask this is regarding the section B, complete section B. Six questions were asked of 1 marks, and three questions were asked no basically of 2 marks. So total weightage was around 10 marks for this particular section. Now coming to the question number one. Now as you can see this question, uh, try reading this one. A uniform light cylinder beam AB of section modulus EI, right? It is pinned by a frictionless joint A. It is pinned by frictionless joint A to the ground and a support by a light inextensible cable CB to hang a weight W as shown in the figure. If the maximum value of the W to avoid the buckling of the beam AB is obtained as beta pi square EI, where pi is nothing but the ratio of circumference to the diameter of the circle. Now they are asking what is the value of beta, right? You can just note down this diagram. So this is a particular AB beam which has been uh, pinned by joint A as well as pinned by joint B, where at the B it is being connected with the load W as well as inextensible cable CB, right? So if I draw the free body diagram here, if I just take the free body diagram of a joint B, if we take a joint B, now here one more thing, they have mentioned that G value in this downward direction, that means it is in the vertical plane. It is not in the horizontal plane, it is in the vertical plane, right? Now, coming to the joint B, you can see here what are all the forces which are acting. First of all, weight W is acting, right? Which is being there at the point B, at the joint B. Now, there is an inextensible cable which is being subjected to what? Tensile force. So, if suppose the wire is there, for example, we have this wire like this. Here you can see A, B, C. Now, whatever the here, my dear friend, this CB will be there. It will be subjected to what? Tensile force. Let's say the force is what? CB. Let's say the force is what? CB. And what is the AB? This AB will be subjected to what, guys? A compressive force. This AB will be subjected to compressive force, for example, FAB. So now if I just transfer the forces at the joint B, so definitely the force which is going to be transmitted at the joint B will be what? Force CB like this. You can see in the figure, just for the reference. And what about the force in the member AB? It will try to push this particular joint B like this. So this is a joint B, guys. Now, what are the angles we have? We have the angles like here it is 30°. What about the angle between the other two forces? Like what about this angle? This is 150°. What about this one? This is a 90°. And what is the complete angle here to here? It will be 90 plus 30, that is 120°. Now, what you can do? Either you can solve this by you can find the forces AB and force CB in terms of W, but there are two methods. One is the Lamis theorem, and second is what, guys? Summation of forces in the x direction, summation of forces in the y direction. That need to be equated to 0 for the joint B, right? So what I'm just doing, I'm following what? Lamis theorem. We can apply this particular Lamis theorem, guys. Why we can apply? Because at a particular joint, how many forces are there? At a particular joint, we have the three forces, right? Out of the three forces, one force is known. So it is very simple to get the other two forces, by using this Lami's theorem. What is the Lami's theorem? Suppose we are adding W, then you need to take the ratio of W and the sine of angle between the two other forces. So if you are taking the load W, what is the angle between the two other forces, FCB and FAB? It will be 150 degree. What about the force AB? Force AB. If you are considering the force AB, then you need to take sine of angle between two other forces, which is nothing but 120 degree. 120 degree. Now, no need to find it out force in the member of CB because it is not required. So what about force AB here? So if you calculate force AB sine 120 is nothing but root 3 by 2. And what about sine? What about sine 150, guys? What about sine? You know, what about sine 150? So it is 1 upon 2. So this and this will be cancelling out. So what about force AB? Force AB will be root 3 times of W, guys. The force AB will be root 3 times of W. Just please make a note of it. Now this is a force which is responsible for buckling of the particular member AB, because a member AB is subjected to what? Compressive force, right? Whatever the inextensible cable is there, it is subjected to what? Tensile force. It will not be under buckling. But what about beam AB is there? It is subjected to what? Compressive force. The moment it is subjected to compressive force, what is the maximum value of the force? What is the maximum value of the force AB that can lead to the buckling? That is about critical load, right? So here we know that critical load formula, P critical, which is nothing but if your value of W will be keep on increasing, then force AB will also be keep on increasing, and that may be equal to what? Critical load. What is the critical load? Pi square EI minimum divided by effective length square. This is the value of force AB. This is the value of force AB. That is the critical load, right? Then only the buckling we can see in the particular beam AB, right? Now, what about the effective length? Effective length is basically what? L times of alpha. But here in this particular problem, whatever the joint A is there, that is a pin joint. What is the joint B? That is also pin joint. So this particular column is subjected to what? It is nothing but pin support. For pin support, what we know, guys? For pin support, we know that alpha is what? Alpha is what, guys? 1. So what we can write here? Force AB. Force AB we can write pi square EI divided by L square. What about length? Length is given in the problem like 2.5 meter, guys. That is the value of length, right? So what we can write further here? Force AB is equal to pi square EI divided by 2.5 square. What is the force AB value? We know that it is root 3 times of W. So from here, what is the value of W, guys? Pi square EI divided by 2.5 whole square into root 3. Now you try to find it out in terms of some coefficient. What is the coefficient value? 2.5 square into root 3. 1 upon that value is what? 0.0924 pi square EI. In the problem, what they have given, guys? In the problem, they have said that the maximum value of the W to avoid the buckling of the AB is obtained as beta pi square EI. So W can be written as beta pi square EI, where beta is what, guys? 0.0924. So what should be the correct answer? Correct answer should be A. The correct answer should be A, guys. Here. Right. So whatever the value of W should be there, right? whatever the value of W should be there, that should be less than or equal to this particular 0.09924 pi square EI to avoid the buckling. If it is just equal to this value, the value of what will happen, guys? The W will be maximum. In that case, FA will be what? Is also going to be maximum, and that will be equal to what? Critical load. And the moment the value of load will become equal to critical load, and if you provide the disturbances, then definitely buckling will be taking place in the beam AB. There is nothing gonna happen with the inextensible CB, right? In the inextensible CB wire, there will not be any kind of buckling because it is subjected to tensile force, right? So this should be the answer. Now try to note down the question number 2 here. Now this particular question is from the machine design, but the problem is that why people, basically student face the trouble in solving this particular question is because of they focus too much on riveted joint, bolted joints. Of course, we have the bolted joint, but there is a one more chapter called power screws there, right? What all the types of threads are there, right? What all the basically efficiency of these square threads? What is the efficiency of the Acme thread? What is the torque required to lift or to basically rise or to lower the load? These are the topic which are there in the what, guys? Power screw, right? And for machine design, you can refer the VB Bhandari book, right? That is the best book. So in gate examination, you cannot leave any corner topic, and you should not be get into the flow by looking at the previous year question trend. Like if they keep on asking the question from the riveted, see, a riveted joint, bolted joint is a kind of investment, right? If once you study this one question definitely will be there, and you can see in this session also one question. But you should not ignore the other topic which is not been asked on a regular basis. So that is what the secret of whatever the question being prepared in the gate exam, right? A square threaded screw is used to. This is a very simple question, but become very tough when you don't know anything about this particular topic. A square threaded screw is to lift a load W. If I just show you the diagram of here, you might be remembering this particular diagram. There is a screw thread basically, under power screw or under mechanical devices. We have, guys, different types of devices, mechanical devices. Whatever the screw jack is there, right? Screw jack is one of the device which is used to rise or lower the load. In the screw jack, there may be different types of thread, but we use a simple square thread. And this is the question regarding the simple square thread, guys. Right now, what is a simple square thread? If you see simple square thread, this is a simple square thread, right? The angle between here and here will be what, guys? It's a 90-degree. And whatever the pitch from here to here, this is nothing but P. This is also pitch P by 2. Because it's a square, so whatever the dimensions will be there, that is exactly same. Now coming to the thread profile, let me show you the rough figure. This is a very rough figure, guys. You can see this threading profile. Something like this, we have the thread profile over there. Right, guys, here you can just assume like this. Here we have the core diameter. We have outer diameter, core diameter, that is the minimum diameter, and there is a mean diameter, and there is a mean diameter. Mean diameter is what, guys? Core diameter plus outer diameter divided by 2. With the help of this screw thread, what we are going to do, we are going to either rise the load or lower the load, right? We are going to rise the load or lower the load. Now Generally, in this particular topic, student getting confused in two terms. One is efficiency, other is what mechanical advantage. If I write down the formula of mechanical advantage, so it is nothing but force output. That is nothing but output force divided by input force, which you guys used to study in the theory of machine, right? In the mechanism chapter. Now, force of output. What we need to do, guys, we need to lift a load W, right? That is my output. How much of input we are giving? We are giving applying the force what? F. So this is a formula for, B option is formula for what, guys? It's a mechanical advantage. There is a no formula for F by W. That is irrelevant, right? Now, so in this way we can eliminate the options. Now, second thing is that what is the efficiency? So efficiency basically we used to write like this: work done by W by load W per revolution to the ratio of work done by effort F. I'm calling this as effort F per revolution. Simply you have to remember the work done by the load W to the what? Work done by the effort. That is the efficiency. And what is the option which is matching to this one? Basically what? A. If you look at the D option, they have just reversed it. 1 upon efficiency, there is a no term. This particular option is what, guys? 1 upon efficiency. And we don't have any name for that. Right? How to derive the efficiency? Why we are getting per revolutions? All these things you need to go through the derivations. Right? Here I'm not discussing anything regarding that because simply it is a 1 mark. So just try to remember what are all the fundamental things are there. Right, guys? So this is regarding the machine design power screw chapter, right? Now coming to the strength of material problem. Here you can just look at the options very carefully. Assuming the material considered in each statement is homogeneous, isotropic, and linear elastic. And it's a quite obvious, right? Otherwise, if we don't assume homogeneous isotropic, then definitely we need to consider Young's modulus in x, y, z directions. But we are considering Ex is equal to Ey is equal to what? What, guys? Ex is equal to Ey is equal to Ez is equal to E in any random axis will be what, guys? E. Just because of homogeneous and isotropic property of the materials. Of course, in reality, we don't have such material, but still, we are just making ideal assumptions so that we can frame the equations, and that equation we can apply to what? A real problem, right? And it's a linear elastic material, right? Of course, you need to follow the any material that is being studied in the strength of material that need to be follow Hooke's law. And very important, deformations are within the elastic range. That means we should not cross the elastic limit point, guys. Here, if you just see stress versus strain diagram, so you can see this. If I just take the any uh, formable steel, so only we need to load till this P point. This is our working zone in a strength of material. If you are loading beyond that, then all these theories of failure may not give the satisfactory results, right? Now, coming to the question, which one or more of the following statement is true, right? That means this is the MSQ problem, right? First statement they are asking: a body is subjected to hydrostatic pressure, has no shear stress. Second statement, let us focus one statement at a time. A body is subjected to hydrostatic pressure. Now, what is the meaning of hydrostatic pressure, guys? Whenever mm, any fluid element, right? If you see the fluid element, I'm taking one example of cubical element, which is being subjected to hydrostatic pressure from all the directions. From all the direction, guys, like this. That means if you just say this particular axis to be sigma x minus p, guys. This is the hydrostatic state of stress conditions. right guys? Now, what they're saying, a body subjected to hydrostatic pressure has no shear stress. Now, what is the tau is theta? Suppose if you are just writing for the plane stress, I'm just finding this tau in tau about z axis, for example, tau about z axis. So I'm considering this is x, this is y, and this is z. Now, guys, understand this is the p value. This is the p value, for example, and this is nothing but xy plane. For example, this is nothing but xy plane. In xy plane, guys, what is my consideration here? I'm calculating the tau about z axis. Tau is theta. I'm taking one angle, a plane which is there at an angle theta, and I need to find on that plane what is my shear stress. Everybody know what is the formula, guys? Here, sigma x minus sigma y by 2 sine 2 theta minus tau xy cos 2 theta, guys. Right? Please note down. So this is what the formula, guys, we have for tau is theta. This particular in hydrostatic state of stress condition, no plane is subjected to what? Tau xy. Tau xy is 0, tau yz is 0, tau zx is 0. I'm just calculating for one plane, xy plane, right? Tau about z axis. So if you just calculate, guys, sigma x, sigma y all are equal. So this term will be gone. This term automatically gone. So what you're understanding, guys? If you take any plane, tau is theta 0 means what, guys? Any plane, whether it is being inclined at an angle 0 degree, 2 degree, 3 degree, 10 degree, 90 degree, 180 degree, in all the plane, the shear stress will be 0. That means a body which is subjected to hydrostatic state of stress conditions, it will be free from shear stress. Then you can also conclude one more statement. Under hydrostatic state of stress condition, every plane is a what, guys? Principal plane. Every plane is what, guys? Principal plane. At If I ask you how many planes are there at a point there is a infinite planes. All those infinite planes will be what, guys? All these infinite planes are what, guys? Principal planes. They are free from the shear stress. So whatever the statement number one is there, that is correct. Coming to the second one, if a long steel rod it is subjected to tensile load, then its volume will be increases. Obviously, will increase, right? Now, if you take the long steel rod, for example, now by just looking at the diagram of deformations, you might be thinking, sir, length is increasing, but what about diameter? Diameter is decreasing. So whether volume will increase or it decrease, so we can't say anything about that. But if you just try to find it out, the volumetric strain 1 minus 2 mu by E, sigma x plus sigma y plus sigma z. For a particular material, mu value will be less than 0.5 because they have mentioned that a steel rod basically what, guys? Poisson ratio is less than 0.5, right? E value is also positive. So what about 1 minus 2 mu by E? This value will be positive. What about sigma x? Sigma x is what, guys? P divided by area. Sigma y, it is subjected to what? Tensile load. Sigma y is 0, sigma z is 0. So what about volumetric strain, guys? The volumetric strain will be positive. That means what about change in volume? Change in volume will be positive means what, guys? Volume will increase, right? So what about this B? B will also be correct. Now, guys, what they have mentioned here, C statement. The maximum shear stress theory is suitable for failure analysis of brittle material. No. Whatever the maximum shear stress theory is there, it is very much suited and it is a very conservative theory for what, guys? Ductile material, not brittle material. Why? Brittle materials are very, very weak in tension, guys. If you take a cast iron, if you take a mirror, a little bit of tensile load you just apply, it will break. It will break. It will not sustain. But if you try to twist it, it may able to survive for some period of time. So brittle materials are very, very strong in shear, but very weak in tension, guys. But if we consider this particular maximum shear stress theory and its statement, they have considered only the shear stress. They have not considered anything regarding the maximum normal stress in their analysis. So if they are considering only the maximum shear stress and maximum, what, just a moment. Yeah, sorry guys. So here I was discussing here maximum shear stress theory is considering only the no basically what guys maximum shear stress. So it is very good for ductile material because ductile materials are very weak in shear. They are very strong in tensile, right? If you see the metal forming, we always make the rod for metal forming is what guys ductile material so that we can pull it off to any length in a particular drawing operations. But brittle material we cannot do that. So this statement is wrong, right? So what is the best theory for brittle material? Rankine's theory, because Rankine's theory is considered maximum normal stress, the stress which is responsible for a failure of a brittle material, right? So that is the best theory for brittle material. Coming to the D option, if you see the D option, guys, what they have mentioned again, if a portion of a beam has a zero shear force, then the corresponding portion of the elastic curve will always be straight. No, for this, let me discuss separately the slopes and deflection here. If we have this shear force, guys, if we have the bending moment, if we have the radius of curvature here R, and here you have the shape of elastic curve. Knowledge of elastic curve is very important, guys, to know how the deflection will be taking place in case of slopes and deflections. Now, here, if you have the first case where the shear force is zero, bending moment is zero, the radius of curvature will be infinite, and this will be straight line. Now, how? Now, see, guys, understand. If you have a certain example, for example, like this, suppose or consider a portion ABC. In the portion BC, if you take from left hand side or right hand side, you don't have any kind of shear force. You don't have any kind of bending moment. Everything is zero, right? Shear force in the member BC, bending moment in the member BC is zero. If you see the bending equation, M by I is equal to sigma by Y is equal to E by R. If you just consider only these two things, what you are going to get, guys? R is equal to what, guys? E by M, EI by M. If bending moment is zero, what about radius of curvature? Radius of curvature will be infinite. If that is infinite, then which particular curve is having a radius of curvature as infinite? Only straight line. So how the deflection will look like, guys? Now in the particular member AB, there is a shear force, there is a variable bending moment. If there is a non-zero shear force, second is non-zero shear force, and there is a variable bending moment, as you can see. Definitely radius of curvature will also varies, and we can have shape of the elastic curve as parabolic, guys. The third one I'm writing case here. Suppose we have zero shear force, but the bending moment is constant, just like we seen in the pure bending case, right? That is the assumptions of a bending chapter, right? Then what about this, guys? M will be constant. M will be constant is what, guys? Radius of curvature will be constant. If the radius of curvature will be constant, then you know that which curve is having a constant radius of curvature, guys? It's a circular shape, which is nothing but circular arc. In this particular AB, if I want to draw the shape of the elastic curve, it will look like this. There is a parabolic variations from A to B, and then from here to here, guys. Here there is a parabolic variation, and then here you have for B to C there is a straight line. Right. These are the things which are very, very important to know for solving the no, for calculation of the deflection. For example, if they are asking what is the deflection at a point C, so you can calculate very easily. Deflection at a point B, and this is what, guys? Let's suppose this is Y, and Y is what, guys? Theta B into whatever the length of BC. In this way, you can calculate total deflection C, delta B plus Y. If you don't know the in between B to C, there is a straight line variation. You cannot say theta B here and theta B here will be same, right? This theta B and this theta B will not be same if it is not a straight line. So you need to understand the shape of the elastic curve also, right? So please make a note of it. In the statement, what they have given, guys, if you read the statement once again, or let me read it. If a portion of a beam has a zero shear force means we have the two possibility, 1 and 3. Then the corresponding portion of the elastic curve will always be straight line. See, in the first case, when the bending moment is 0, then definitely straight line. But always, this is not correct. Once we have the zero shear force, but the bending moment is constant in case of pure bending. What is the third case? It's a pure bending case. It's a pure bending case. What is the example of pure bending? For example, a cantilever beam subjected to end moment like this. It's a pure bending moment case, guys. You can see the shear force 0, but the bending moment is what, guys? Constant throughout the length of the beam. So radius of curvature will be constant, but shape of the elastic curve will not be straight line. So D statement is also incorrect. So what should be the correct answer? AB should be correct. Right, guys. So these are the things table we used to discuss in every class for every batches in every year, right? Coming to the next question, guys. Again, regarding the what we have machine design fatigue strength. Now read the problem very carefully. Which of the following statement, which of the following method can improve? Let me, yeah. Which of the following method can improve the fatigue strength of a circular mild steel shaft? Right. Now, which of the following can improve the fatigue strength, guys? Obviously, enhancing the surface finish obviously will increase the fatigue strength, because you know that if there is a surface roughness, if there is a surface roughness, there will be cracks. If there is a cracks, guys, what will happen? If there is a cracks, if there is a surface roughness, when there is a crack, what will happen, guys? The surface finish factor will decrease. When the surface finish factor will decrease, what about the endurance strength, which is modified endurance strength? Sigma E into Ka into Kb into Kc. When Ka will decrease, sigma E will also decrease. So what you can understand, guys, endurance strength will decrease. But if you try to increase this no, basically improve the surface roughness, that means what will happen? If you try to enhance the surface finish, then what will happen? Cracks will decrease, Ka will increase, sigma E will increase. That is the best method, right? Second, short pinning of the shaft. That is also one of the method. Short pinning means we will try to introduce the compressive stresses onto the material before putting this material into what functionality. That means we try to do, suppose we take a steel ball and we try to throw it. That is a short pinning. When you do the short pinning, we will try to introduce the compressive stresses. Now, why we introduce the compressive stresses? I will explain. Coming to the next option, relative humidity. When you try to increase the humidity, humidity will cause the corrosions. And if there is a humidity, it may lead to more and more corrosion, more crack formation will be there, right? So if you try to increase the relative humidity, corrosion will increase. What will happen with the corrosion? Crack formation will increase, right? Because of corrosion, crack formation will be there. Again, crack will try to reduce the surface finish factor, or we can say that this particular factor K, and it will try to lead to decrease the endurance strength sigma E star. So what is the best thing? We need to decrease the relative humidity. Now coming to the short pinning of the shaft, how the compressive stresses will try to decrease or basically will be not harmful regarding this endurance strength. You know the famous graph everybody must be knowing, the variable stress versus mean stress. This is negative, this is positive. So you know that for example we have from here, sorry, we have from here to here, we have sigma E, we have guys sigma YT. What you're understanding guys, when you try to apply the mean tensile stress, if it is increasing, you can see that the moment if I increase the mean tensile stress, what will happen, guys? If you try to increase the mean tensile stress, you can see that what is happening with the graph. What is happening with the graph, guys? See, for this particular value, sorry, for this particular value, guys, understand. For this particular value of mean tensile stress sigma 1, what is the value of endurance strength? Sigma E1. For this particular value of sigma M2, what is the value of sigma? What is the value of this particular value, guys? For example, this is the value of variable stress. For example, this is the variable stress sigma V1, sigma V2. You can see, guys, as we keep on increasing, the mean tensile stress, what will happen? The chances of failure is more and more. Why? Because this graph is getting what? In the downward directions. That means endurance strength is keep on decreasing. Endurance strength is keep on decreasing. But the moment you apply the compressive stress, the moment you apply the compressive stress, what will happen, guys? The moment you apply the compressive stresses, what will happen, guys? If you try to see, the moment you apply the compressive stresses, there will not be, see, you keep on applying the compressive stress, there will not be any effect on endurance strength. It will be constant. It will be constant. So compressive stress, whenever you introduce the compressive stress, always there is a no harmless because it is a very, very, what we say, as you can see, there is a, when we apply the mean tensile stress, the chances of failure is more and more, right? Sigma E is decreasing. That means chances of failure is what? The chances of failure is increasing. But when you apply the mean compressive forces, sigma E will remain same. When sigma E will remain same, the chances of failure will also be less. So better try to introduce the compressive stress all the time. Now, what are all the best method we have? We have the cold working, we have the surface treatment. What are all the surface treatment operation we have, like nitriding, carburizing, case hardening. On the basis of this particular treatment, what we can do, we can decrease the cracks, because everything is depending on what, guys? Cracks. Because whenever there is a crack, when you apply the tensile force, this crack will be elongated. This crack will become larger and larger. When the crack will become larger and larger, and the material will become too sensitive for a particular crack, the moment you start rotating that material, what will happen, guys? It will fail. It will fail. That is a fatigue failure, we say, right? So what we are trying to say in that, because of this short pinning with the help of a steel ball, we will try to introduce the compressive stresses, and that compressive stresses will try to decrease the tensile stress, right? So A, B, D, all these options are correct. Now coming to this particular question regarding the strength of material, once again here, try to read this particular problem. Yeah, guys, what you can understand from here, L-shaped elastic member ABC with the cylinder arm AB and BC of uniform cross section is clamped at a point A and it is connected to the pin at a end C. The pin remains in a continuous contact with the particular member and it is constrained to move in a smooth horizontal slot. That means this particular member can only move in the horizontal slot here and here. That means it cannot move in a vertical directions. So from here, one thing we got to know that the net deflections of a point C has to be zero. The vertical deflection of a point C has to be zero because it is only moving in the horizontal directions. It cannot move. It cannot break the slot and come out and move in the downward directions, right? That is not possible. The end C is subjected to the horizontal force P, and all the reflections are there in the plane of the figure. Given that the length of AB and BC is something like that, 4A and A, the magnitude and direction of a normal force on the pin from the slot respectively. We'll try to draw the diagram first. This is A, this is B, this is C. If you see the figure, the end C is subjected to what, guys? End C is subjected to force P, and there is some forces which are acting from a slot onto the pin. For example, I am applying the forces like this. This is what I'm applying the reaction force R. And R we need to find, guys. We need to find the R. This is the 4A and this is A. Now try understanding, guys, what is the next thing? Whenever we have any structural problem, blindly we need to follow out Castiglione's theorem. Blindly what we need to follow, guys? Castiglione's theorem. What is the Castiglione's theorem? First of all, find it out the total strain energy of AB and BC member. Try to differentiate with respect to the R because that will give the vertical deflections. That will give the vertical deflection at a point C, and that vertical deflection will be zero. The two step you will get the answer, but we need to find the first step. What is the strain energy for AB? For finding the strain energy, we need to find the moment. What is the moment in the member AB, guys? If we just transfer the load R and P to there, what will happen, guys? If we just transfer the load P, it is subjected to P like this and P into A. That is the moment which is being acting, right? If we transfer the load P from a particular C to B, what will happen, guys? There is a tensile force P as well as there is a moment. What about R? R will be simply, it will be transferred like this. If we take any section at a distance x, and if you write the moment in the member AB at a section xx, then you can write R into x plus P into A plus P into A plus P into A, right? That is the particularly moment we know. My dear friend, what I'm doing, I'm just basically writing the strain energy formula due to bending. Everybody know that this particular formula mxx square dx divided by 2ei. Mxx square dx divided by 2ei, guys. You need to understand this particular thing, right? Now, what is the next particular task? The next particular task is to calculate the values of this particular strain energy for AB as well as BC. To simplify the task, what I'm doing, guys, I'm directly differentiating this equation with respect to R. If I write the difference in the particularly differential format, then what we can write is 2mxxx dou m by dou R into dx divided by 2ei. So what we need to do, guys, we need to just differentiate it with respect to R. So this will become x because this term will be 0. So it is finally x. What about movement in the member BC? What about movement in the member BC at a distance x? Tell me guys. P into X. P into X. But if you try to differentiate BC with respect to R, you will get 0. So what about BC term, guys? BC term will be 0. I'm saying strain energy will be there, but BC, why this term will be 0? Because total differentiation, if you do, what are you doing? Dou U by du total divided by dou R, what you can write? If you try to differentiate, you can write here like this. For member AB, which is nothing but 0 to 4A, M M in the member AB, dou M AB divided by dou R dx divided by EI plus 0 to A MBC dou MBC divided by dou R into dx divided by EI. This is the vertical deflection, and that we need to equal to 0 because we know that the vertical deflection is 0, guys. So what is the MAB? Everybody know that MAB is what, guys? Just now we have written. It's a RX into PA into X into dx divided by EI. 0 to 4A plus MBC is there. MBC is there, P into X. But what about dou M by this value? This value is 0. Then whole term will be what, guys? It's 0. Whole term will be 0, guys. So what we can write here? R into x square divided by 2. Sorry. Here this value, if you multiply, what will happen, guys? Here R into x square dx 0 to 4A plus P into A x ds equal to 0. X cube divided by 3 plus P into A R divided by 3 64A cube is to 60 square is equal to 0. So my dear friend, if you try to calculate what you can get here, you will get R value as minus 3P by, what you can get, guys? 3P by 8. That means whatever the direction you have assumed, that you need to reverse the directions. It is acting in the downward directions. So if you see 3P by 8, which is going to be acting in the downward direction, this would be correct. That means whatever the reaction force, whatever the direction of a normal force on a pin will be what, guys? It is like this. It is like this. That is the reaction force offered by the slot on a pin, right? Now coming to the last question, this one. Try to see this question, guys. Again, I told you, right? This question again from the riveted joints. So that is a permanently one question is being asked from this section, right? In the machine design. A bracket is being attached to the vertical column by means of two identical rivets U and V. It is being separated by the distance of 2A, which is equal to 100 mm, as shown in the figure. The permissible shear stress of the rivet material, the permissible shear stress is 50 megapascal. If the load is 10 kilonewton, is applied at an eccentricity of 3 root 7A, the minimum cross-sectional area of each rivet will be what, guys? It will be what? Now here, so with this bracket, you have load P at a distance of, just a moment, guys. Diagram is important. You cannot solve in air, right? Each and every things need to be clear. And what about this distance? It's a two-way. The two-way value is also given as 100 mm. Means A is what, guys? 50 mm. A is 50 mm. Very first of all, tell me, if you just transfer the load to the center of gravity, for example, here, this is the center of gravity. If we transfer the load P here, I'm applying the two load. You can see that I'm applying the two load. P like this, P like this. So this P and this P will basically what? What is the equivalent diagram? Equivalent diagram will look like this. The equivalent diagram will look something like this. There is a P and there is a some twisting moment, P into E. That is a twisting moment. That is the equivalent diagram from the bracket to the particular rivets, right? Now, why I'm calling twisting moment? Because whatever the moment which is being there, this moment is parallel to the cross sections plane. If this moment is parallel to the cross section plane, that is a twisting moment. If it is a perpendicular, that is a bending moment, right? So because of the P, there is a first of all one primary forces. Primary shear forces will be introduced. What are the primary shear forces? What are all the primary shear forces, guys? Very first of all, what are all the primary shear forces? The primary shear forces, you can see that it will be developed like this. Both will be sheared off. It's a primary shear force. And how to calculate the primary shear force? PP1 is equal to PP2, which is equal to P by 2. They will be equally distributed. What is the P value, guys? P value is given as 10 kilonewton divided by 2, which is nothing but 5 kilonewton. Each rivets will be subjected to this much of primary shear force, PP. Primary shear force. What about twisting moment? Twisting moment will try to shear off because of the what? It will by introducing the torsional shear stress. Now, so what will happen, guys? These are the rivets, and it will basically applying the twisting moment like this. So what will happen, guys? Based on the from the center of gravity to this particular distance, for example, this is a distance R1, this is a distance R2. I'm calling this as a rivet number 1, rivet number 2. They will try to introduce the secondary shear force Fs1, Fs2, or PS2, PS1, for example. Secondary shear force. How to calculate the secondary shear force, guys? It's a very simple, very simple. Total torque created by the resistant torque which is created by this particular rivets is equal to what? The torque which is being acting. The torque which is being acting, right? So what is the primary shear force? PS1 into R1. PS1 into R1, for example. That is the resistant moment which is being offered by the rivet number 1 plus PS2 into R2. That is equal to twisting moment P into E. But we also know that the secondary shear force is directly proportional to radius. The secondary shear force is directly proportional to radius. The more and more radial distance from the center of gravity, the more and more secondary shear force will be there because that will try to introduce more and more twisting moment, more torsional shear stresses, right? Let's suppose PS is what? K times of R. So it is K times of R1 square plus K times of R2 square, which is nothing but P into E. So from here, what is the K value, guys? P into E divided by R1 square plus R2 square. You can see from the figure what is the R1 and R2. It's a very simple, guys. From here to here, what are the value, guys? It's a 50 mm. R1 which is equal to R2, which is nothing but what, guys? It's a 50 mm. It's a 50 mm, guys, right? And what is the value of E? The E value which is being given in the problem that 3 root 7a. 3 root 7a. Where A is what, guys? 50 mm. So from here, what is the K value, guys? 10 into 1000. 3 root 7 into A. What is the A? 50. What is the R1? R1 and R2 both are same. 50 square into 2. From here, what is the value of K, guys? Just try to calculate the K value. 10 into 1000. 3 into root 7 into 50 divided by 50 square divided by 2. So you are going to get 793.725. But what about PS1, which is equal to PS2? K times of R1, K times of R2. So from here, what you can get, guys? PS1, which is equal to PS2, 793.725 into 50. So if you just try to calculate, you are going to get 39,686.269 Newton, which you can also calculate PS1 is equal to PS2, 39.686 kilonewton. Now, if you see, my dear friend, for example, both the rivets are very critical rivets, both the rivets. So secondary shear force is basically what, guys? PS2, PS1 is acting like this, and PS1 is PP1 is acting like this. Both making an angle, what, guys? 90 degrees. So what is the resultant load? Again, I'm saying you can follow any rivets. Both the rivets are critical rivets, right? PP1 is square plus PS1 is square plus 2PP1 PS1 into cos 90 degree. This value will be 0. So what is the resultant load? PP1. What is the PP1? 5 square plus, because it's a 5 kilonewton, plus 39.686 square. So from here, what is the value of R, guys? If you try to calculate the R value, you are going to get 40 kilonewton. Once you get the R value, guys, because of this particular R, my dear friend, what will happen? Because of the R value which you got, resultant load is what, guys? 40 kilonewton. This 40 kilonewton, that is nothing but it's including the shear forces, which is because of the primary and secondary. So ultimately, it is a shear force, right? Shear force divided by area. What I'm going to get, guys? I'm going to get this particular value is basically what? It is nothing but maximum shear stress. This maximum shear stress should be less than permissible shear stress. Yes or no? Then 40 into 1000 over area, that should be less than or equal to what, guys? Top permissible, which is nothing but 50 megapascal. So if we try to calculate, the minimum to minimum cross sectional area should be what, guys? More than or equal to what? 800 mm square. A should be correct. Just have a look at this. So it's a very simple one, right? We already solved in the machine design 4 rivets like this. In GATE examination, what they have done, guys? They have simplified. They have simplified to only 2 particular rivets. That's it. They have removed this one. So already we have solved the tough problem than this one. So this is not a very tough one, right? Only we need to understand what all the forces will be developed. Here, primary shear force, secondary shear force. There's no role of normal stresses or normal forces. But the moment if I change the loading like this, then everything will change. Everything will change, guys. Or maybe if I just change the plane of a loading, again it will change. Again it will change. So you need to understand this thing. How to transfer the load from the application of the load at the point of the loading to the center of gravity. Again, if you want to transfer the load, introduce 2 equal and opposite forces and then see the effect of that. Just like what we did here. The effect of this P will be what? Will be acting in this direction only. Effect of P will be effect of P only, which will shear off. And because of that, there is a primary shear force will be introduced. But what about this P and this P? They will try to create the twisting moment, right? I hope that you understand this particular session, whatever the things we have done here regarding this particular set 1. In our next session, we are going to cover the same strength of material and machine design, for GATE 2022 set 2. Before that, we will see again this particular problem. I think this is the last problem. Again, this question is from the what, guys? This question is from the strength of material. So try to look at into this particular question. A thin-walled cylindrical pressure vessel has a mean wall thickness of T and the nominal radius R. The Poisson ratio. So first of all, note on the data. The Poisson ratio is what, guys? 1 upon 3. When it was subjected to some internal pressure, its a nominal parameter in the cylindrical portion is increased by what, guys? Increased by 0.1 percentage. Correspondingly, wall thickness is what, guys? T bar. The corresponding change in the wall thickness will be what? So first time when they asked this question, it was not known to anyone because the concept is not being conveyed, right? So in this particular thing, we need to understand there is a apart from the hoop strain and longitudinal strain, we have one more strain that is called a radial strain. We have the radial stress also, which is nothing but pressure, but it is very very small as compared to what, guys? Hoop stress and longitudinal stress, right? So how to solve this one? What is the hoop strain? Sigma h upon E minus mu times of sigma L upon E. Again, minus mu times of radial stress upon E. But here, radial stress we are neglecting as compared to what? Hoop and longitudinal stress, because the radial stress is very, very small as compared to hoop and longitudinal stress. Right, guys? What is the hoop stress? PD divided by 2D. And what is the longitudinal stress? PD divided by 4T. Now, putting these values, what we can get, guys? Hoop strain. Hoop strain we can get like PD divided by 2TE, 4TE, 2 minus mu. Everybody must be aware of this one, right? What they have given in the problem, read the particular problem, guys. Read the particular problem, what they have given. They have given in the problem, it is subjected to some internal pressure. It's a nominal parameter. Nominal parameter means what, guys? Nominal radius. That means there is a radial strain. What is happening with the radius? The radius is getting increased by 0.1%. That means what, guys? The hoop strain value they have given in the problem, 0.1 percentage. From here, we can calculate PD divided by OTE. 0.1 divided by 100 into 2 minus 1 upon 3. If you try to calculate what you can get from here, 2 minus 1 upon 3 into 100. So you are going to get 3 divided by 5000. Now what we need to find? We need to find the change in thickness over the original thickness. So directly we need to find the radial strain. What is the radial strain, guys? Change in thickness by original thickness, which is nothing but sigma r upon E minus mu into sigma h plus sigma L upon E. But this is zero because everybody know that it's a very very small as compared to what we have hoop as well as longitudinal stress in the thin cylinder. Then what we can write here, guys? Here delta T divided by T, which is nothing but minus mu divided by E, PD divided by 2T plus PD divided by 4T. Further, what you can get, guys? Minus 3 mu divided by 4E, PD divided by T. So from here, what you can get, guys? Change in thickness by original thickness as here 1 upon 3. PD divided by 4T, already we know these values, which is nothing but 3 divided by 5000. Right? If you try to calculate 3 divided by 5000, you are going to get minus 6 into 10 power minus 4. But they are asking what, guys? Percentage. If you try to calculate in percentage, what you can get, guys? Minus 0.06 percentage. So how much of changes are happening in the thickness? Thickness will reduce by 0.06 percentage. Right? So what should be the answer, guys? The answer must be minus 0.0. Minus is very, very important, guys. They are not asking only magnitude. They are asking the corresponding changes in the wall thickness. Final thickness minus original thickness by final thickness, by original thickness. Change in thickness, what they are asking, guys? Change in thickness by original thickness into 100. And that is what we got the answer, right? So these are the things, guys, you need to understand while solving the problem, right? Thank you.